interesting about the fact that when I check the power curves or the mean power curves, and also the mean wind speed, it looks like this deviation of 4 degrees has lower performance than 6 degrees, which is theoretically not. No, it doesn't make sense, because even though the 0 is not the real set point, may not be the real set point, 0 is always the one that has the highest performance. So you expect that a deviation, the closer to that 0 deviation, whatever it is, should be higher. But yeah, I noticed the opposite. It is 6 actually behaving better. I'm not sure if you guys noticed that as well.
Well,
but
how did you calculate it?
Oh, no, I just simply divided by periods. Like all the data, I gather all the data. So yeah, I can just calculate the mean per wind speed being. I think it was 0.1 meter per second.
Yeah.
So I just plot the curves, and looks like it was like that. Also, I kind of make some density estimation about the histograms of the wind speed, and they because there's always the possibility that for some reason when you got 4 degrees you got lower wind speeds, so you expect that there is less power because there were lower wind speeds, but actually you get more upwind during these 4 degrees. So that's why I kind of can it gives some hints that maybe this 4 degrees is actually more misaligned than 6.
Yeah, at some point, I can't find it right now, but at some point we had I think similar thing. So we just plotted the power curve of each label, and it's the same thing. I think that's not in here. It's not in. That's the maximum power radon. Yeah, no, it's not in here. I need to find it. But I think I remember that exactly that happening. Like the power curve actually looked lower for the 4 degrees case than it did from the 6 degrees case, which doesn't make any sense at all. Which is why I was saying that maybe that's without even doing any analysis, right? That's just like looking at the results. Which is why we were wondering if the angles are not actually doing what we're telling it should do. Eugenio, you wanted to say something about that? I can try to find the plots while I'm waiting.
No problem. I just want to know if the wind speed data of the turbine is already corrected with the transfer function, nacelle transfer function.
The wind speed data is not corrected by anything.
Okay, is the raw?
Okay.
Okay.
You mean with the losses over the rotor? Or what do you mean?
Yes. So I think that both algorithms that we are running here could have problem in that scenario. I have to check it.
So I think the wind speed data we've got is just the wind speed on the nacelle.
Yeah, but to compare, for example, if you have the proprietary power curve of the wind turbine, if you compare the power curve measured with this wind speed data, it will not be comparable because the wind speed is actually behind the rotor, so you have the all the wake effects on this wind speed data, and thus it's not possible to compare with, for example, a reference power curve, and some analysis of one of these proprietary algorithms that I talked about depends on, but I have to check it.
What does OpenOA do actually? Is OpenOA supposed to take the nacelle wind speed, or does it think it's taking the the actual inflow conditions.
Yeah, but in some way, so I don't know. Yeah, I don't know. In this case, in the case of OpenOAD, I'm not sure if it's expecting raw wind speed data from the nacelle, or if it's expecting nacelle wind speed corrected with the transfer function. Maybe
Yeah.
there is something in the documentation, but this can be a problem.
Yeah. By the way, just while we were talking, I actually found these power curves. So
Oh, yeah.
we've so I mean that's the bin averaged data. I mean the raw data is like that. It's very difficult to see. But if you bin average them, I mean it's difficult to tell, isn't it? Because you don't know how many data points there are at each bin. But generally at most of the, let's say the normal operating period, you actually have a lower performance at 4 than you do at 6. But okay, it's a bit lower up here, but which is kind of weird. So I am wondering if that just means that the data is basically rubbish. I mean, what we could do is that we could try to apply your methods or OpenOA as well to the Nadara challenge, because we actually have we have some ground truth data where they independently measured the yaw. So
that's my idea for the future steps. Actually, we are trying to start the work with this new data, and overall, it's important to note that maybe, for example, in the 6 degrees offset, the wind speed data is also affected by the misalignment itself, because the misalignment affects how the wind speed, how the rotor influences the wind speed. So we are, with the LiDAR data, it's possible to verify that comparing the power curve based on the anemometer, you can have really big mistakes. For example, what we have a scenario is a very it was a very huge misalignment, above 15 degrees. And in that case, if you when you correct the misalignment and compare the power curves, if you make a power curve comparison using the LiDAR data, you can see on that wind turbine, for example, 90% of AEP gains. But if you use the anemometer, that was not faulty, it was we just shifted the wind turbine, and when you look to the power curve based on the nacelle anemometer, you found a gain of 22 and so on %. So it's was very biased by the misalignment. We are not sure, and on that point, it's a preliminary result, but we are not sure if there is really no problem on that anemometer. But we was not expecting so much difference from one period to another period. And the anemometer for now doesn't look faulty, okay? But
so this guy here, Philip, he in the chat where we wrote our results, he said he suggests calibrating the wind speed measurements with regards to wind vane angle by doing a linear fit against the neighboring turbine's wind speed. And the thing is, we don't have for this data set, we don't have the neighboring wind turbine, but I think for the Nadara one, there are loads of wind turbines. So I think maybe that's another topic that we can just basically say this data set is very difficult to work out all these problems with this data set, which is also a good learning experience.
Yes. we can try to understand better how, for example, a scenario with more, for example, well, we don't have the data correctly about the transfer function, and there's a lot of difficulties about this data set, and we are understanding how this affects our algorithms. So that's important as well, because we start to know the limitation about the SCADA-based methods. So understand the limitations is so important as understand if it works or not.
Of course, yeah, and I think even some of these findings are would be quite worth reporting in a conference or something, that we can say, yeah, these limitations of the different methods, and this is what we actually need. Could be pretty interesting. But yeah, if the conclusion is we need to try it on the Nadara challenge, but there's probably going to be some limitations to the Nadara data as well, because I think even one of the questions what somebody asked the other day was to do with the amount of data. I can't remember anymore. I noticed that you'd written a question actually. Eugenio, they haven't replied yet, have they? I emailed them today actually to tell them to reply to that question about the Area 5 data, but someone else asked a question about the number, the amount of data. So there's like only, I don't know exactly, but maybe we can talk about that in the next Nadara meeting.
Oh, that's important. That's a
Yeah,
real
I
good
can't really.
question.
I'm not really. I have to get Yuri from my team to answer it. I haven't really been involved with the data exactly myself, but it says that there's quite a lot of missing data, but I think that might be a misunderstanding if we have to read the data description again to remind myself. Let me think about it. Yeah, I think we purposely only provided a subset of information about the ground truth yaw misalignment. We purposely didn't supply it for all data points, or we didn't have it for all of them, or both. I can't quite remember anymore. But anyway, I think we have to talk about that at the Nadara meeting, which I can't remember when that is. But so are you two in the position to at least summarize what you've done? Because I think it would just be even valuable just to have these three summaries, sort of the finish to the challenge. So Eugenio, I made you a document.
Okay.
I made you a document here, but maybe I don't call it interim anymore. You can change the name. You should be able to edit this document.
Okay.
And I think, Juan, if you want to make a little report about what you did as well, I have to give you
sure.
I have to give you access. So what I can just do now is that I can just let me see if I can do it as I'm speaking. Should be able to duplicate this one. Feel free to change the name, or you can write whatever you want. I think the best thing to do is just to write a bit of text and copy and paste some pictures in. So I just copied that, and then I have to give you. I think Eugenio already gave you moderator access.
Yes.
And
Yes.
I think you already told me that you had access to that. So I need to do the same with Khan as well. I'll just put that there so you know where to write.
Yeah.
And then I have to give you, well, I can wait, I have to make it visible. Don't notify. And then I put that, so that's the second one. And then I have to give you the rights here to do that. Members. If I give you change space role moderator, I think we established that now if you reload it, you should now see
Let me double check here.
You should be able to see this edit button. Does it work?
Yeah, I have edit access.
All right,
So
cool.
so I can do it. So far, what I've done is just data exploration, because I just checked the previous solutions that the normal maximum point is not enough. So the
Yeah.
idea is to figure out why, right? Mm,
I think anything you did would be interesting. Just, I mean,
mhm,
we've got, at the moment, we've only got 3 entries really, and even our entry is not really a detailed analysis or anything. It's just very basic. So I think even if we just have these 3 things and we can come to some conclusion like what we just said about some of the limitations and the challenges, I think that's still an interesting result, and I think it's still worth presenting on. There might be a couple of other people submitting stuff. I did ask Philip, for example, but I can't really quite remember. I think somebody wanted to participate but then didn't have time anymore. But I still think it's probably worth just having a final presentation in the next meeting, and then making a proper conclusion, and then we can think about if we've got enough to write a paper or an abstract, or just to do a blog article and present what we learned. As a minimum, we can still do that, just even with the three groups. So, and maybe we can try to get the people from the Nadara challenge as well to listen to what we've got to say. Are you 2 both available on the next meeting on the 17th of June? Am I even available on the 10th?
17th of June. Yeah.
Yeah, I
I
will be
will be.
available probably.
Yeah, okay. I have like a presentation until 3:10. I might have to move it till 3:15 or something, but I'll let you know anyway.
Okay.
All right, sounds good. Is there anything else you wanted to talk about?
No, I was just curious because I arrived just when you guys were talking. Eugenio, you talk about a proprietary algorithm you guys have?
Yes.
That-
Is a project that we have here in Brazil with a company, and we was subjecting this proprietary algorithm to the to this challenge data, and we probably will make the same things with the Niagara challenge.
Oh, okay.
So probably I will have. I cannot share exactly how this algorithm work, but I can share the assumptions of the algorithm that about how it works, and it's enough to understand. Actually, it's not very different from what you can see on the literature about SCADA-based methods. But I cannot by myself write exactly how this works because I have an NDA, and so on.
Yeah, no problem. But you said that you already tested, or you are or you will plan to test with this data?
We tested this proprietary algorithm with LiDAR data that we get in Brazil.
Okay.
And we also tested this data with this challenge, but with the challenge it not worked as expected, and we are still trying to figure out why it not worked, because we validated with the LiDAR. So
Yeah.
theoretically, the LiDAR is the ground truth. So we are trying to understand what was the limitations of the data set that makes it difficult to the algorithm work on that scenario.
Okay, I got it. Yeah. I don't know, guys, if you are familiarized with this work, I think 2 years ago from Davide Astolfi and collaborators. using dual anode measurements. The method is based on that assumption of the not that assumption is something that it is proven the impact of the misalignment on the anemometers. So their method needs the turbine to have two anemometers.
Yeah.
Like in so, and actually I'm working with a company here in Ireland, and yeah, that method has worked with us. We have a study case with that, and it's much better and more robust if you have this dual anode and actually simple. Yeah, so
Yes,
I
yes,
think yeah.
I already read this paper
Mm-hmm,
from Astolf. It's very interesting. Do not have the opportunity to test it here yet
mm-hmm.
because these wind turbines that we put the LiDAR just have one anemometer, so we
Yeah,
kind
yeah,
of
that's the
not.
thing, because the
Yes,
two anemometers have to be together, like very
yes,
close one to the other. But yeah, okay, yeah. Okay. Good to know that you
but
are aware of that. Yeah.
we try to implement or replicate this stuff method
Mm-hmm.
on the Kelmarsh dataset. But
Oh,
as the Kelmarsh dataset, we do not have a ground truth. It's not.
mm-hmm,
It's difficult to say. I successfully replicated the method, but I don't
mm-hmm.
know
Yeah.
because I do not
And
have
that's what we
a ground
actually, that
truth.
was the whole intention of making this new data set was to do that. But we've basically realized that we haven't really got a ground truth because we don't, obviously, it seems to be the case that we don't actually have the yaw angles that we thought we had. So
Yeah,
yeah, that's why I'm hoping that some of the
Mm-hmm.
Nadara data that's got the ground truth on maybe could be useful for
yeah,
that. But what we can't do with the Nadara data is show how this dual anemometer method would work because we don't have any data with a dual anemometer either. But
Yeah,
um,
that's a problem. I just comment because it's kind of disencouraging because most of the literature has found that SCADA exclusively based methods are very limited for this
yeah,
problem in particular.
yeah,
But yeah, I think that in my experience with these study cases that I have with also LiDAR, I got better results with the dual anode. So maybe is
mm,
that will be the path in the future. But it is still really interesting.
mm,
Trying to find without any other
yeah,
uh, more more
yeah.
sensors.
mm,
Yeah.
I am trying to I am checking if this can work or not, but using the Era 5 meteorological data. So
Hmm.
you get external meteorological data as a supplementary source of data to improve the algorithm. But obviously it cannot replace the second anemometer. Is not the case here
Yeah.
is other proposed, but I think that maybe it's possible. I think in my experience as well, use
unless
the
you're in
shaded.
mountainous terrain.
Yeah.
Yes,
It's going to be
yes,
quite, I mean, this is a bit also one of the problems with having it anonymous, right? If they want to keep it anonymous, they don't want to tell us the location. If we don't know the location, it's going to be difficult. Like, let's say if it does work with that data, it might do for that one because, I don't know, maybe the weather state, maybe the point is really close to the wind farm or it's really flat there, but it doesn't really, or if it doesn't work, it could be because it's in the mountains. It would be good to get a feeling for how much information about the position that they would be willing to give us. Like maybe they will give us the data and tell us at least how far away the point is, or they have some
yeah,
correlation with a met mast, even without having the raw data. So I think it's definitely worth having a conversation about. I mean, at the end of the day, they're trying to do something which is it's going to be actually useful for them, and so I think having any of this reanalysis data as part of the method is perfectly reasonable. So I personally think that they could be persuaded to use it. So let's see what they say. I can't actually remember when is an interim meeting coming up on Monday, or is it? No, it's not on Monday. Is it actually before the I can't even. Let me have a look. Because we have the at the WeDoWind International Symposium, we're actually going to work on the challenge, and there are two people from Nadara are going to be there.
Yeah.
I'm just trying to work out which of those comes first. So the interim webinar is supposed to be on the 15th of June, which is like a week before. Okay, so on the 15th of June we can ask them.
Okay, perfect. Thank you, Sarah.
But you're coming anyway to the event, aren't you, Eugenia? Yeah, you said, I think we talked about it before. That's really cool. Yeah, all right. Then I will, if you two could do your reports. I mean, the official deadline is supposed to be on Sunday. If it's a bit late, it doesn't matter, but the presentation you should do it before the presentation on the 17th, whenever it is, what did we say the presentation was? On the 17th. On the 17th. If you could do it before the presentation on the 17th, and then we can have a proper finish on the 17th and have a presentation and then sort of conclude it. It's a shame that comes 2 days later than the Nadara one, but never mind, we can I think we could try to get people, invite them. On the 15th we can tell the people in the Nadara workshop to come to your presentation on the 17th. We can do that, can't we?
Yes, that's nice.
All right, let me know if you have any questions, and otherwise I'll see you in a month, or no, in a couple of weeks.
Okay.
Yeah.
Okay,
perfect.
thank you so much.
Thank you.
Thank you.
Bye. Bye.
Have a good day. Bye.